Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. What I will be discussing tonight will be the so-called MOV, capital MOV victory. That's a metal oxide varistor. And a view of a metal oxide varistor is this one. It's a so-called variable resistor capacitor, and which this is used to clamp or control or absorb the voltage surges which are coming to our power lines, which try to destroy our electronic equipment. This is a metal oxide varistor. This is newly bought from Amazon, and the serial number of this one is TBR14471. I tried to Google the voltage specification of this one. The average voltage of this one, the maximum voltage that it could take average is 470 volts. So, meaning to say, if the power line voltage is 120, and sometimes there are voltage surges coming into our power lines, if this is connected between the line and neutral of the input line to our equipment, supposing the voltage input one time is 350 volts, and of course our equipment will be burned if that voltage will go inside our equipment. So to protect our equipment, we must have to connect this metal oxide varistor between line and neutral to absorb that 350 volts. As an example, to absorb that 350 volts. So if a voltage surge is with the value 350 volts, this metal oxide varistor could handle that one. So instead of that voltage going into our equipment, that voltage surge will be absorbed by this metal oxide varistor. Okay? So with that value 350 volts, rest assured that the equipment after the line will still be in good condition, meaning the transistors, the other ICs inside will still be intact. But without this metal oxide varistor, for sure, with the voltage surge or spike of 350 volts, okay, the power supply of that equipment will be burned ASAP without this metal oxide varistor. So the importance of this metal oxide varistor or surge protector is actually to absorb the abnormal voltage which are inputted randomly to our power lines when some things occurred. And those occurrences are actually just like if an air conditioner is shut off, since an air conditioner got a motor, and since it got a motor, there will be a voltage coming into the other component of the circuit, which might burn the electronic equipment. So actually, air conditioners is actually a very dangerous thing also, because if it shuts down, there's the so-called voltage that it will generate back to the other power lines inside the house, and it might damage the lower voltage equipment that are plugged in to the house. So to avoid the occurrence of that smaller voltage equipment plug into our house outlets, we must have to use a metal oxide varistor or a surge protector. If a lightning will occur, that's the so-called very dangerous one, because a voltage spike coming from a lightning striking our transmission lines. Of course, if the transmission lines are struck by lightning, there will be a big voltage going into our houses. Okay? This surge protector could not handle that one. So the other protection that will be needed for a lightning to occur, it will be the so-called lightning arrestor. So as of now, I'm just discussing small voltage surges, meaning voltage surges from the range 0 to 600 volts. Okay? Like my example, if there is a voltage surge of 350 volts, okay, and the voltage specification of this surge protector is 600, it could handle that 350 volts. Okay, it will absorb that 350 volts instead of that voltage going into our equipment, so it protects our equipment. And how do we know if our metal oxide varistor or surge protector is good or not? This is a newly bought one. The proper way on how to know if this surge protector is good or bad is actually to measure. You will be getting your multitester. You will set it on the ohm range. Okay. Then try to measure the resistance between the two terminals. Try to measure the resistance. Okay. And for a voltage surge protector to be in good condition, the reading should be OL. It should be an open circuit. It should be an open circuit. Meaning to say, if the surge protector is in good condition, its resistance is actually, it's open circuit. Or it could be in the range of million ohms maybe. 10 millions will be fine, but if it's OL, much more better. OL is actually an open circuit. But 10 million or 15 million, it will be fine. So the one I bought at Amazon right now is in good condition because the reading across the terminals is OL. It's infinity. The resistance between the two terminals is open. Okay? So it is ready to absorb any voltage surge. I will try to check the other one. It got a reading. It's not a small reading. It's in the million ohms reading. So there's a reading of around 7 million ohms. 7 million ohms, it's fine. Okay? As long as the reading is in the million range, it's fine. This is actually 8 million ohms, the second one. I will try to check the third one. Oh, this is bigger. It's 11 million ohms. 11 million. So that's fine. As long as the value is not 0 or in the range 0 to 100 ohms, that metal oxide varistor is good. So this one here is 11 million ohms. This one here is a perfect one. It's an OL. It's an open circuit. I will try to check the last one. The last one is still an OL. It's an open circuit. So the first one, the fourth one, and the fifth one is OL. It's an open circuit. For the second and third, this is at 7 million ohms, and this is 11 million ohms. These two here are still good, but the first, the fourth, and the fifth is better because it's an open circuit. They are ready to absorb any overvoltage in the range of, like for this TBR 14471, the average voltage spike that it could handle is 470 volts, but it could handle any voltage from 11 volts AC to 680 volts AC. Okay? So if there is an intentional overvoltage on the line coming in, the one that will protect our equipment will be this metal oxide varistor, and I will try to shut off this one. So we now know how to determine if our surge protector are good or not. The connection of the metal oxide varistor is this one here. It is connected between line and neutral. That is after the fuse or circuit breaker. Okay? It should be after the fuse. Because if there is a voltage surge, the one that will absorb the overvoltage is actually this metal oxide varistor. It will try to short out itself. Okay? So if it will try to short out itself, it is killing the voltage supply going to the equipment, and supposed to be the fuse or circuit breaker will be blown. So we know when the fuse or circuit breaker is blown, okay, there's a short circuit, and the next thing we will be checking will be the metal oxide varistor. If just in case the resistance of the metal oxide varistor is 0, meaning it is shorted, it had protected the circuit from overvoltage by shorting itself. So if it shorts itself, of course the fuse or circuit breaker will be blown, and of course the equipment is safe from burning. Okay, that's the connection of the metal oxide varistor or surge protector. So the important thing here is the metal oxide varistor, when it is good, the resistance between the terminals should be open, or it will be in the range million ohms. 7 million, 11 million will be fine. But if it's an OL or open circuit, when you test it, it's very good. Okay? So at least we now know the importance of metal oxide varistor, or simply a surge protector. It should be rated, if you try to buy this one, you should know what will be the maximum voltage that it could handle. For this one I bought, the maximum voltage that it could handle is 680 volts AC. Because sometimes, like what I said, if an air conditioner shuts down, there is the so-called back EMF going to our lines, and that back EMF is actually an alternating current voltage, which might be greater than 120 volts CP if we are here in the United States of America. So if so happen that you got smaller equipment connected near a circuit of an air conditioner, just make sure that the other circuits, low voltage circuits, should have a surge protector to protect them from burning. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes.